Good afternoon, all. Bikesh sir, I am audible there? Yes.
Yes, Pradeep, you're audible.
Good afternoon, all dear participants. We are having the speaker for this second session with us. Let me introduce the speaker, sir. We are having with us Dr. Bikesh Kumar Singh. He is a professor there in the Department of Biomedical Engineering, NIT Raipur. And his current research areas are biomedical signal processing, medical image processing, computer-aided diagnosis, medical image classification, and applications of machine learning. He has been awarded with various award like Chhattisgarh Young Scientist Awards. He is a gold medalist in his university when he studied, and he has several best paper award with him. Now I am handing over to Bikesh sir to continue this session as a speaker. Sir, please continue as a speaker.
Okay, thank you, Pradeep. I'll be sharing my screen.
Yes, sir.
Whether my screen is visible?
Yes, sir. Yes, sir. Your screen is visible and you are audible also.
Okay.
One thing is, sir, that in the last we are planning that we will be having a question answer session with you, sir.
Okay.
Participant have to they have to raise hand, and I will unmute from here, and they will ask directly. They can ask directly. Otherwise, what they will do, they can also ask the question in the chat session. It is the chat session is also visible to the sir also. Okay. Yes, sir. You can continue, sir. Please.
Okay. So good morning. I think good afternoon to all of you. Sorry for late by a few minutes. Actually, I was just confused that I thought my session is from 1. As per the yesterday's schedule, the second session was at 1, so I was in that mindset. So I'll be talking about different supervised and unsupervised learning techniques, and the topic which was given to me, that is supervised and unsupervised learning. And obviously ANN is a supervised learning technique, so I'll be talking a little bit about ANN. As far as I know, there was a detailed lecture on ANN in yesterday's class, but still because I will be giving you an example of ANN, because how this supervised learning is done using ANN. So I'll just go through a brief introduction. We'll just revise what was taught yesterday, and then we'll continue. So just a minute, I'll just adjust my pen with the system, and then in 30 seconds I'll start. Okay, so basically when you say supervised learning, unsupervised learning, what's happening? Okay, so when you say supervised and unsupervised learning, some problem is there, I cannot. Okay, yeah. So as you all have studied yesterday, that in artificial neural network or in any machine learning techniques, learning plays a very important role. Okay, so whenever you develop a model, maybe the model based on machine learning or deep learning or artificial intelligence, artificial intelligence, learning is the core part of the model, that what learning technique you are using to train the model. Better will be the learning, better will be the performance of the model. So this learning actually comes in machine learning. Means when we say learning, supervised learning, unsupervised learning, it is actually a part of machine learning or deep learning. That learning comes from here. Okay. So we'll be talking about classification and clustering using machine learning, and we'll be talking in that, I'll be talking about how supervised and unsupervised learning is conducted. Now, when you say machine learning, machine learning involves different steps. There are many steps in machine learning. Okay, so for example, you talk about data. You talk about data acquisition. So data acquisition, it can be signal, it can be image. So different domains are there. It can be pathological data, it can be any type of data, satellite data, climate data, a lot of, every field. All the nowadays, all disciplines have applications in machine learning has application in all the disciplines. Okay, so the first thing is data, and after that data, like for example, if it is signal or image, you do some pre-processing to clean the data. So we go for pre-processing to clean the data, to remove any noise or any artifact. And after cleaning the data, you go for feature extraction. So this feature extraction plays very important role in learning, because whatever features you extract, like for example, if I have to classify the people, that among a group of people who are tall and who are short, so I will need some feature, maybe the height of the person, that will be the main feature while categorizing the short heighted and short and long heighted people. So features play key role in the learning process. So either it is signal or image, you will extract features, and then you will select some reliable features. So that will be based on what? Feature selection. So those who are marking, they might be, these are terms are very common in the machine learning pipeline or paradigm. Feature selection, sometimes, people do statistical analysis also. So this statistical analysis, for example, man Whitney U test, or K or this T test, ANOVA test, these techniques are also used to establish the significance of features. So we, out of the total extracted features, we select the most relevant features, and on the basis of that features, now these features are used to develop the model, or to, for the learning of the model, so model now learns with the help of these features. Okay, so this is what is meaning of learning. Actually, learning simply means that on the basis of some data, on the depending upon the data that is available, the model which you develop learns from that data, and after learning we test the model with some new inputs. Like for example, you gave some inputs here. Now those inputs can be again given for evaluating the model or testing the model. Okay, so this is the basic pipeline of machine learning, and at present in this workshop, particularly in this session, we are concentrating in learning. That is how model learns from the data. So to proceed further, I'll just give you the brief background of what you studied yesterday, that traditional programming and machine learning or computerized programming. So in the traditional programming, what we do, we give data as well as we give program, and we get the output. Like for example, if I want to say add some numbers, addition, subtraction, division, multiplication, these are simple operations, and for that we'll give data, we'll write a program. Whenever we give input, we'll get output depending upon the input. Okay, so program is first written, and then input is given, and we get the output from the program. That is the traditional programming, that we give problem to the model and we get the solution. But in case of machine learning, we give data, we along with the data we give this output also. Output is also available with us. Like for example, in this case, in the example which we just discussed, suppose I have 200 or 300 or 500 data samples, we say samples. Okay, Like I have 500 signals or 200 signals which are available with me, and like for example, uh, I have some sort of signal, say ECG signal, that is electrocardiogram, corresponding to two groups. One is diseased, it can be any disease, I'm not going specific, and the other can be healthy. Okay, so I have a ECG signal and I have its category also, that whether that ECG signal belongs to a diseased group or it belongs to a healthy group. That category is also available with me. This category is called label. This category is called label. Sometimes it is also called ground truth. It is also called ground truth. Okay, so in normal, in traditional programming, what will be done is that they will write a program. So program is available to you, you will give ECG, and at the output should be whether it is diseased or not diseased or healthy. But in machine learning, what happens, we give the complete data. So complete data means multiple examples of ECG signal, because ECG signal is not common for different people, depending upon the size of the heart and different cardiovascular conditions. The ECG pattern will change. So different examples of ECG, and along with that its output. So its output means the ground truth. Both are given to the computer as a program or final model, which is used to categorize the disease. That whether the first I'll develop the model. So for developing the model, I'll give data, I'll give output, I'll get a program. This program is my final model, and then this model will be ready to be tested. And when I test the model, then I give my data or input, and I'll get the output. This is what happens in the machine learning area. Okay, so when you give this data and output to the computer, what actually computer does? Computer learns from this data. Here in this case, in the previous case, you don't give the output, so no learning is there. No learning is there. Here you are giving the data as well as its class or its category. That if this is the ECG, then the category is what? Diseased. If this is the ECG, the category is healthy. So you give both data as well as its category, which we are calling it here it as output, and then we get a final model or that program, and then this program can be used to now categorize some unknown data. Unknown data means new data. So I'm giving a new ECG, and then model will tell me that whether that ECG corresponds to healthy subject or the diseased subject. This is what is the difference between traditional learning and traditional programming and machine learning. Okay, and this, when you give data and output, what computer does? Computer actually learns, and based on the learning, we get a program. Based on the learning, we get a program. So what we do in machine learning? In machine learning, we are doing what? We are, so as you can see here, that we are giving different problems to the model, and we are training the computer, we are training the model. Okay, so these different problems means you can just assume that these are different ECGs, many ECGs. We are giving to the model so that model can get trained first. And along with the ECG, we are also giving the label. Label means the class or the category or the ground truth. That is also given along with the problem. Means the problem is given as well as its solution is given, and we train the model. And finally, we get a so this model, after this training, the model gets trained, and then you give a new problem to the model, and the model gives us solution. So this is what is in case of traditional programming. If you give a new problem, the model will not give you the solution because model is not trained. Like for example, if you have designed a program for addition, adding maybe 2-digit numbers, it will not add 3-digit numbers. Okay, because this is simply a program. There is no learning is not involved here. Okay, so why this learning is required, or means why machine learning is important rather. Okay, now there is a huge data set nowadays, because earlier what was happening, because now the communication and information technology has advanced a lot, so because of which lot of data is available. But earlier so much data was getting, so much of data was difficult, because most of the things were manual. Okay, most of the things were like either it is any clinical data or hospital data or any type of data. The data, most of the data was recorded manually. But nowadays, because of availability of computers are easily available in all the different departments, and available, and increase in the information and communication technology, so the data set, availability of data set is not a problem. So we have huge data set. And just just think that if a person has to remember so much of data, if I have to remember so much data, it's very difficult for me. So huge data sets are available, and it is difficult for a person to naturally remember so much of data. It is difficult to analyze them, not only to remember them, to analyze them also. To address this issue, we can have, not to analyze and then to classify also. Okay, that this data belongs to this class or this class or this class or this class. So manually these things, this is very difficult, and that's why we need machine learning. So machine learning basically, so I hope you all understood what is machine learning. Machine learning is nothing but it comes under the umbrella of artificial intelligence. Artificial intelligence is a complete umbrella, and under that umbrella we have machine learning, we have deep learning, we have optimization, lot of other when you say artificial intelligence, it is automation. It is more towards automation. Okay, but machine learning is the software part of that automation. So the different types of machine learning are, just now I hope you understood what is learning. Learning simply means we have some data and we have the label of that data. Label means category of that data or ground truth of that data. We call it as ground truth or label or class. So many names are there. These all are same. If I have 500 ECGs, 250 belong to healthy, 250 belong to disease. So this disease and healthy is nothing but category or label or class. So if we have data and we have label, we can give it to a model, and model can learn. This type of learning is called supervised learning. This type of learning is called supervised learning, in which the label is available to us. The label is available with us. The ground truth is available with us. So what we can do, we can give that label to the model along with the data, and model can learn. The machine learns from the training data and labels. So labels are also available. And based on that learning, the model will do prediction. This is called as supervised learning. On the other hand, the second type of learning is unsupervised learning. The second type of learning is unsupervised learning. In unsupervised learning, this label data is not available. This label data is not, means the labels are not available. So in unsupervised learning, what happens that we have several data, we have multiple data, but the label of that data is not available. Then also learning takes place. So how the learning will take place? If labels are available, learning is bit easier, because the along with the data, its label is also available. But when label is not available, in that case, the learning is called unsupervised learning. And what happens in unsupervised learning is, like I told you, that suppose I have to classify the height, whether short height or long height or mid height. So even if the label is not available, there will be some characteristics by which I can at least determine that these individuals are short heighted, these individuals are mid heighted, and these are long heighted. Okay. So what happens in unsupervised learning is that, depending upon some characteristics of the data, depending upon the some characteristics of the data, because I have so many data. So some characteristics will be obtained from each sample, and based on that characteristics, I will group the data into, I'll divide the data into different groups. Okay, like for example, you just see this small figure here, this figure. So I have huge number of points. I have huge number of points in this. Now, depending upon the location of the point, depending upon the what is the coordinate of the point. So according to some characteristics, I will say that these points belong to one group. These points belong to another group. And based on that, I will whether some network issue was there, right? Hello. Okay.
No, sir.
Okay,
Yes, sir.
everybody is saying yes. May I know from which up to what I completed? Just a minute, I'll first share the slide. Can some participant tell me up to what I completed? Up to what the network was there? Any one of you? Okay, somebody wrote something in chat. Okay, unsupervised learning. Okay. So I was telling that in unsupervised learning, what happens is that the label is not available. The label is not available, but on the basis of some criteria, the algorithm automatically categorizes different samples. Okay, like for example, I have just assume that I have lot of samples of rose petals, and I have lot of samples of petals of, say, sunflower. Okay, these are the two labels. The labels are not available, but I have mixed data. So I have multiple petals of rose and sunflower. They are mixed with each other. And now in unsupervised learning, what will happen? Some features will be extracted from these petals. So what can be the features? The features can be color of the petal, length of the petal, width of the petal. So these are some characteristics, and on the basis of these characteristics, the algorithm automatically determines that there are two groups. Whether it is a rose group or sunflower group, that may be unknown. But at least the model will determine that, okay, there are two groups. One will have certain different characteristics, and the other group will have certain different characteristics. This is the second type of learning. Coming to the third type of learning, it is reinforcement learning. In reinforcement learning, what happens? It is kind of semi-supervised, we can say. It is kind of semi-supervised. So during the learning process, so machine learns on its own. And during the learning process, machine receives rewards and punishments. It means that if the machine is able to classify that, okay, this is rose petal, so because the machine is correct, some score will be given to the machine. Some reward some kind of reward will be given to the machine. And if it is wrong, some kind of punishment will be given to the machine, so that machine automatically learns that, okay, what is rose and what is sunflower. I think there will be one figure here. Yeah. So these again the same thing, that is supervised, unsupervised reinforcement learning. And this is what I discussed actually in the previous, in the first slide, that this is the block diagram of supervised learning technique. Okay, we have data, we do feature extraction. A feature selection process is not shown here, but generally after feature extraction, feature selection is there. Based on the extracted features and the label or the ground truth, training model is trained, and then the trained model is ready for what? Prediction. And then once the model is ready for prediction, we give new data. Again we extract features, and based on the extracted features, model gives us the label of unknown data or the new data. This is supervised learning. So support vector machine, neural networks, naive bayes, decision trees, knn, all these are examples of supervised learning techniques. And unsupervised learning, the algorithm, based on some characteristics, based on some criteria, divides the whole data into different clusters. So there are how many clusters in the given example? 5 clusters: black, orange, red, blue, yellow. In the third case, reinforcement learning, the model is such that it learns automatically. Whenever it uh, achieves a wrong target, then we give some kind of punishment, or we say we give minus 50 points to the model. So model automatically understands that next time avoid this kind of avoid this because I am being punished. Okay, so this type of learning is called. So at least in reinforcement learning also, we are helping the model to learn. Okay, so that's why it is called semi-supervised learning, because we are giving rewards and punishments. So it is kind of semi-supervised learning, and the examples are Markov decision process and Q learning. And in unsupervised learning, we have K-means clustering, fuzzy C-means clustering, hierarchical clustering. These are different clustering techniques. So unsupervised learning is also called clustering. Why it is called clustering? Because ultimately what is done here? Ultimately what is done here, data is available and we are dividing the data into different clusters. Okay, and it is very so for example, in real time scenario, whenever you have some data, like I told you that um, I have a brain MRI image. Okay, I have a brain MRI image. So we work in medical applications. So I'm taking that example. So suppose I have a brain MRI image and I have to divide the different regions of brain using, I have to cluster or divide the different regions of brain. So gray matter, white matter, fluid, or there will be different tissues. There may be some tumor, suppose. Okay. So it is very difficult to decide the number of clusters. That how number of clusters means number of groups. In supervised learning, that is available in prior. In supervised learning, it was available that this is healthy and this is disease. So number of groups are known to us, that is two groups, healthy and diseased. But in unsupervised, it is not known. When the number of groups are not known, or the groups names are also not known, we go for unsupervised learning. So in MRI image, because there are so many portions in the brain, it is very difficult to decide the number of clusters. So how they are decided? They are decided empirically. Empirically, you can say by hit and trial. Okay, like for initially take 3 clusters, then 4 clusters, then 5 clusters, and there are some techniques also for tuning these things. So this supervised and unsupervised learning, this supervised learning can be used either for classification or for regression. So classification simply means to categorize diseased, healthy. This can be the category. Severity, mild, severe. Okay, so this can be the classification. Low grade, mid grade, high grade. This can be the classification. So in classification, they try to predict a discrete number of class labels, one or zero, pass or fail, healthy or diseased. Okay, but in regression, in the output that is obtained is not in discrete form, it is a continuous valued output. It is a continuous valued output, and that continuous valued output can be in the form of 50.3, 2.8, anything. It can be anything. So this type of problems are called regression problems. So for example, the example which is given here, that based on the student profile, the student profile can be like, for example, if I'm trying to find out that whether the student will pass in engineering first sem, so what type of student profile may be needed, what was his percent in 12th, what was his or her percent in 10th, family background, schooling background, lot of things can be the parameters. And on the basis of the parameters, if I decide, the model should be able to decide whether the student will pass in engineering or fail in engineering. Okay. Similarly, in regression, instead of pass or fail, we want to predict what will be the percentage of the student. Okay, so it is continuous. The percentage can be 50 or 60 or 80.2. So it is a continuous valued output. Such problems are called regression problems. Okay, so I think this slide we have already discussed. Classifiers are of two types, or the learning mainly it is of two types, supervised and unsupervised. So we have already discussed that. Now, okay, so before discussing this confusion matrix, I hope you all understood that how we define a problem for learning. Okay, how we define a problem for learning. Before learning, what are the steps that should be followed? I'll just take one example and try to explain that, and then we'll go to the exact neural network. Okay, so as I told you, that when you design a machine learning problem, or when you develop a machine learning problem, you need a data, and then you extract features. Okay, you extract features. So when you extract the features, after feature extraction, what we get? So for example, just assume that I have to classify the petals of rose and sunflower. Okay, I have 100 rose petals and I have 100 petals of sunflower. The first thing will be, so this is my data. From data I have to extract features. So I'll have to extract the features from each rose petal and each sunflower petal. Maybe suppose I am assuming that the data is available in form of image to me. Data is in form of image. I have images of rose petals, I have images of petals of sunflower, and now I want to extract features. The first can be color feature. So let the first feature be color, or rather than color, because color has a different approach, color extraction has a different approach. Let me take simply, so I have 200 petals. So 1 2 3 4 5 dot 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 200. Out of this 200, hundreds are rose, hundreds are sunflower, and out of this, from each of the petals, I am extracting some features. So let the features be petal length, sorry, PETAL, petal length, petal width. Let it be this much only, two features. Okay, so this will have some first petal will have some length and width, second will have, so we'll get a data will be of size 200 into 2. Data will be of size 200 into 2. Okay, once this data is, I'm excluding feature selection and everything, because number of features which we are taking is only 2. So feature selection is not important here. Feature selection is generally used when we have large number of features, maybe 100 features or something. In real time examples, for example, in real time image classification or signal classification, we may have 50 features or 100 features. So in that case, feature selection will will be there. feature selection will be there. Okay, here I am neglecting feature selection. So I have this table with me. This 200 is indicating number of samples, and this 2 is indicating number of features. Now I have to divide this data into two parts. Divide it into two parts. Why we want to divide it into two parts? So if you see the diagram here, this diagram, this figure, I need to train the model, and at the same time I need to also test the model. I need some new data. Okay, some data for training and some data for testing. So that's why this data division is needed. Okay, so this 200 into 2 samples, this data will be divided into two parts. One will be used for training and other will be used for testing. This training is nothing but learning. Training means we want model to learn. Okay, and for this training, we have to divide this data into two parts. Uh, there are different methods of dividing the data into training and testing. Okay, the simplest one is holdout method. In holdout method, what we do, we randomly, it is completely random technique. Randomly, we divide this whole data into two groups, maybe 70% for training and 30% for testing. So out of 200 samples, I will use 140 for training and 60 for testing. I will use 60 for testing. Okay, so this training data, 140 data, 140 into 2, I will say. Okay, and along with that, there will be one column for label. I missed it here. There will be one column for label also. One column for label, which will contain the label or the category, that whether it is sunflower or rose petal. So it will be actually 140 into 3. This will be given to the model to learn, and then my model will be developed. How the learning takes place, I'll come very shortly. How exact learning के अंदर क्या होता है, I'll come shortly. Okay. So this is given to the model for learning. Coming to the testing part, I have how many samples remaining? 60. After this model is developed, after learning phase, after the learning phase, when the model is developed, when the model is ready to me, I will do testing. So let the testing samples be, say 1, 2, 3, up to 60. Okay. And for this, model will give me some output. I'm not giving the label here to the model. This is simply 60 into 2, not 60 into 3. Not 60 into 3. Here, when you are testing the model, the label is not given. The model gives you the label in form of output. Okay, so I'll get some output, maybe that this is rose petal, this is sunflower petal, this is rose petal, this is sunflower petal. Okay, like this, I'll get some output. And I have its actual label also. Actual label which I left here, the third column. The third column, which is my actual label. It can be rose, 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 first 30 rows and last 30 sunflowers. And now I want to compare the model output with the actual output which was needed. I hope you all are getting the model output and the actual output which I was expecting. So for that, comparing in MATLAB as well as in Python, there are very simple commands for getting this. It is called confusion matrix. For comparing, we need something called as confusion matrix. So in MATLAB, it is a simple command like plot conf We need two things in this. One is the model output, let it be y o, and one is the actual label. Actual label means the real what we needed. Let it be y true t. And now these two will be compared with each other and we'll get this type of matrix. This is the matrix actually. This is called confusion matrix. Why it is called confusion matrix? Because this matrix gives us information about how much the model is confused after training. We have trained the model has learned now after training. So after training, how much the model is confused, that is shown by confusion matrix. That's why it is called confusion matrix. Okay, so see, this is the prediction and this is the observation. So observation means true value, whatever we needed, whatever we observed earlier, and prediction means model output. Prediction means model output, which I am taking yo and this is yt. Okay, and that will be compared. Yes is one group. Yes is one group. Let it be sunflower. No is one group. Rose in our example, sunflower and rose. And how many samples were there? 60. So out of 60, 30 for sunflower, 30 for rose. I'm assuming it. This is test samples. So let this be 25, 26, 4, 5. So what these values give me? So these values indicate what? These values indicate that there were 20, there are out of 30 sunflower petals, 25 petals were actually sunflower, and they are also classified as sunflower. This is called true positive. This is called, please stop me at any time if you don't understand this, okay? This is called true positive. Assuming that sunflower is representing positive and R is representing negative, it can be vice versa also, okay? I'm taking yes as positive and no as negative. Okay, so 25 samples are the samples which were actually sunflower and they are characterized also as sunflower by the model. So this is called true positive. 26 samples are the samples which are actually rose, but they are classified also as rose. You have to see overlapping. This is the overlapping. Na? So this side also rose, this side also rose. Actually rose, classified as rose. This is called true negative, true values. See, this positive negative is simply because S is I am considering S as positive and R is negative. So in the previous example which we took, diseased and healthy. So I'll say diseased can be taken as positive, healthy can be taken as negative. This is simply a notation. Okay. So 26 and 25 both are true values. True values means correctly classified samples. Correctly classified samples. Okay. What about this 4 now? 4 samples are the samples which were actually these 4 samples are the samples which were actually sunflower, but they are classified as rose. They are classified as rose. It means that they were actually positive, but classified as negative. So this is called false negative. This is called false negative. And for the same reason, this 5 is called false positive. This is called false positive. So after learning, when you test the model, you get some output. That output is compared with the actual output. And then this happens in supervised learning. Okay, all these are the part of supervised learning, because in supervised learning, label is available with us. We give the label during training, but we don't give it during testing. Sorry. Okay, and we don't give it during testing. Once you get all these four values, true positive, true negative, false positive, false negative, I can now calculate different performance measures. Different performance measures. So what are the different performance measures? True positive predicted value, total negative predicted value, accuracy, sensitivity, specificity. There are equations for that. We can put these values, ABCD values obtained to get the, obviously accuracy will be total correctly classified samples upon total number of samples. Okay, sensitivity is total positively classified samples. Specificity is total negatively classified samples. Percentage, not total, percentage. Percentage correctly classified samples, accuracy. Percentage positive correctly classified samples, sensitivity. Percentage negative correctly classified negative samples, specificity. These are simply different performance measures, but to calculate these performance measures we need the value of ABCD, rather we should say TP, TN, FPFN. True positive, true negative, false positive, false negative, and after that we can calculate these performance measures. This matrix is called confusion matrix. Why we need this confusion matrix? Why we need such kind of commands? Because see, there were 60 test samples. Okay, and in this 60 test samples, so we have model output, and we have actual output. Actual means which I needed. It is very difficult to compare it one by one. Not for 60 at least you can compare, but just assume when we have 1,000 samples, when you have 1,000 samples, and in that case the test samples will be higher, not only 60. So manually comparing it is very difficult. For that we need some method, and one such method is by plotting confusion matrix. Okay, and another important point is that we discussed here that for dividing the data, we have used holdout method. Okay, but holdout method has some limitations. I'll not discuss it in this session because we want to concentrate more on learning. Okay, so but holdout, other than holdout, we have other methods like cross validation, k-fold cross validation. So if you work in this area, you should use k-fold cross validation for data division, not holdout. But to explain the concept, I just used holdout method, but the accepted one is k-fold. K-fold is more popular. Okay. Am I clear up till now? I'm audible, right? Okay. So now I'll be discussing the first supervised learning technique, artificial neural network. And as I know that this has been already discussed yesterday in very detail, maybe I'll be just taking 5 minutes, 5 to 7 minutes to just summarize it, and then we'll directly go to the part that how learning is done with the help of an example. Okay, so I'll not discuss that what is the difference between traditional computer, ANN. Already we have seen, and you might have seen that yesterday in detail. This analogy also you might have studied yesterday in detail, maybe, that this is the artificial neural network uh, figure, and this artificial neural network is inspired from our biological neuron. So biological neuron, our brain consists of millions of neurons. Okay, and whatever we do, like whatever we react, whatever we do, that is because of the functioning of all these neurons. The neurons are getting fired. So sometimes we become sad, sometimes we become happy, sometimes we got angry, sometimes we are in fear. So all these things depends on what functioning of these neurons. generation of some electrical current and some chemicals inside the brain. Okay, so all these things are responsible for our functioning. Whatever we do, it is the functioning of these neurons and uh, are mainly responsible in that. So I'll just discuss these four components that the neuron. So our brain consists of millions of neurons, and millions of neurons are massively parallelly connected to each other. Okay, that is a very complex architecture. It is very difficult to design such architecture in real time. Okay, but people are trying. Okay, so we have this is a simple diagram of neuron. This is a simple diagram of biological neuron. It has a cell. This is the cell body which acts like a summer. It sums all the inputs. So neuron is nothing but it has a node, you can say, or it has a point in it in which different inputs are received and they are added with each other. They are added with each other. Okay, we'll not go to the biological phenomena. A lot of things are there, but I'll not go into that. Rather, I'll concentrate more on that. You should be just able to pick some concept here, and then we can move forward. So we have some point in the biological neuron also, which is called cell body, and that is a point where signal from the other cells, other neurons are received. So here we have different other neurons, and signals from other neurons are received, and they are added here. This is the cell body. The points from which these inputs are received, the branches from which these inputs are received, are called dendrites. Are called dendrites. Dendrites receive signal from other neurons. You can just assume that these are the dendrites. These are the inputs, are the dendrites. Okay, and each input will have some strength. Each input will have some strength. It's not necessary that millions of neurons are there. One neuron may receive signals from many other neurons. So the signals received from so many different neurons, each will have different strength. That strength is represented by synaptic weight. The strength of this input is called synaptic weight. So these are simply numbers, weights. W1, W2, W3, W. Each input has some weight. Okay, each input has some weight. And we have axon, which transmits signals to other cell. So we have one cell. If I want to design a more complex architecture, I will have multiple cells. So this is one neuron. I can have multiple neurons in the neural network architecture, right? So axon is something which transmits signals to other cells. So we can have multiple neurons. Okay, so what are these axons actually? See, we just studied that there are dendrites. These are the dendrites, okay, which receives information from other cells. These dendrites are actually endpoints of axons. So see, this is axon. These are axon terminals, and these terminals are connected to the dendrites of some other neurons. This is just the uh, correlation. I hope you understood. Now, when these different inputs are received by the cell body, as I told you, that these different inputs will have different strengths. When all of them come to the cell body, these inputs get added. And if this addition sum is above a certain threshold, neuron gets fired. Otherwise, neuron gets not fired. If neuron does not get fired, we will not react. If it gets fired, we will react. That is what is the biological neuron. And the same thing is now here represented in a artificial neural network. In artificial neural network, we have inputs. So in the previous example, we had only two inputs, petal length and petal width. So X1 will be petal length, X2 will be petal width. There will be no X3 and X4 in our previous example, as per our previous example. Each input will have some weight. Initially, I can select these weights randomly. Let it be 0.4 and 0.5. Okay, I will say 0.4 and 0.5. Say length is more important than width, suppose. So length will be given more weight and width will be given less weight. Initially, we can do like that. When we write algorithm, initially we choose it randomly. Then summer will add both this x1 into 0.4 plus x2 into 0.5, and that will be added. I'll get vk. So vk here is what? Vk is output of summer. I will get x1, the first feature, into 0.4 plus x2 into 0.5. This will be my vk. And sometimes another term is also there, which is called bias, is also added, plus bk, which is generally 1 or -1. It is small value. This is simply used to shift the decision boundary from origin. What is decision boundary? Suppose I have a simple problem. I have to classify two data points. Okay, this is one data point and this is another data point. So this is decision boundary. Decision boundary is the line which separates these two groups of data. These type of problems which I have just shown in the figure, they are called linearly separable problems. Linearly separable problems. Okay, and this is called decision boundary. So this decision boundary sometimes can be at the center. Sometimes we have to shift it away from center. So sometimes for that, bias sometimes helps us. That's why we give bias also sometimes. Now you got VK. VK is nothing but the input that is received at this cell body. The input that is received at this cell body. Depending upon the value of this input, we will pass it through a transfer function, or it is also called activation function. And suppose it has some, it is some threshold like kind of thing. Okay, something like this, that if the value of vk or the value of sum is greater than 0, the neuron gets fired. If it is less than 0, the neuron does not get fired. So output is 1 or 0 depending upon whether the sum is greater than 0 or not. Okay, that is conducted by, this operation is performed by activation function. This is how neural network work. We have already, you have already might seen in the last class. And these are the different types of activation functions. We have step function. Above a certain threshold t, output will be 1, otherwise 0. This is sine function. Above, for greater than 0, output is 1. For less than 0, output is -1. This is sigmoid function. Sigmoid function is generally used when we don't need the output in form of 1 and 0 or 1 and -1. I need continuous values, 0.2 through 0.2, 0.1, 0.6. In that case, I'll use this sigmoid function. Okay, so depending upon the value of input, I'll get some output. It can be 0.8 or 0.9, anything. Okay. This is how the whole process takes place. When we practically solve this ANN problem, just remember the previous example. Okay, what was our previous example? Rose and sunflower. Okay, how many inputs? Two inputs, x1 and x2. What is x1? Petal length or petal width. What is x2? Petal length. And then accordingly we had two weights, w1 and w2. So the first step is in the supervised learning process is to initialize these weights and bias also. If you want to include bias, you can include bias also. The first step is to initialize these weights. Okay, weights initialize. After initialization of weights, the next stage is summation bias plus summation of product of weights into input. So this is nothing but w1 into x1 plus w2 into x2, and then adding it with bias. I'll get this equation. Depending upon, if number of inputs are m, I'll get this type of equation. This is very simple. I think you all are clear with this. And finally, we pass it through a activation function. Finally, we pass it through a activation function. activation function finally decides that if the value of sum is greater than 0, the output will be 1. If it is less than 0, the output will be -1. Okay. And then we compute the error. Now this error is what? This error is what? See, just we should recall here that we are studying what? At present, we are studying what? Supervised learning using ANN. Using ANN. These are the steps of supervised learning using ANN. In supervised learning, what are the things which are available to us? We have two things which are available to us: data and its label. So, which is also called category or output or ground truth. So, output is available to us. Okay. So, you gave data to the neural network. How many samples we had for training in our previous example? 140, if you remember. 140 for training, 140 for training and 60 for testing. Testing हमने देख लिया. We are talking about training now. 140 samples we have for training. Okay. For each sample we have two values, x1 and x2. Petal width, petal length. Pehle sample, first sample, for first sample, the value of petal length and petal width is given to the neural network here. Here in this, initialize the weights, two weights w1 and w2, and then perform this w1 x1 plus w2 x2 plus b. Okay, x1 is the petal width, x2 is the petal length. Okay, and then check whether the output which I get, whether the output which I get here is same as the label or not, label of the first sample or not. At present, model is learning, and that's why we are calculating error. Error is nothing but the desired response, which means that the response which I needed, and the actual response. Actual response means this is the actual response. This is the actual response. Output of this transfer function is actual response. Output of this transfer function is actual response. So I'll get either 1 or -1, and then I'll check whether it is same as desired response. Model will check. Model is learning. If this is 0, model will not change the initialized weights. जो weights हमने initialize किया था randomly initially, यहाँ पे, this weights will remain unchanged if this error gets 0 or a very small value. But if this is large, if this error is large, the weights will be updated. And for updation of weights, we need some rule, weight change rule. Weight updation, weight update rule. We need some rule. Okay. And by that rule, the weights will be changed. And again, second sample will be given to the neural network. Same process will be done. Third sample will be given to the neural network. Same process will be done. Every time the weight will change if the error is, if there is an error. Every time this error will be calculated, the weight will change. The weight will change if there is an error. If there is a no error, weight will not change. Are you all getting this? Maybe some participants can reply in chat box, or maybe they can unmute them. Whether you all are getting this? Okay. So, what is the final aim here? The final aim is to find a weight. Just see how much it is complicated. The final aim is to find a weight W1, W2 such that for all the 160 samples, a single final weight W1 and W2 such that for all the 160 samples, For all the 160 samples, Dn should be equal to Yn. The desired response would be equal to the actual response. We have to find a weight such that the error should be minimum for all the samples. ऐसा नहीं होगा कि सबके लिए samples के लिए weight अलग अलग होगा. The aim is to find a weight, a common weight, such that for all the 140 samples, the desired response should be equal to actual response. Then we will say my model is 100% trained. My model is trained with 100% accuracy. Do you think it's possible? Please reply, some of you. Do you think it's possible? Can we find a weight such that it satisfies for all the 140 samples? Okay, so some participants are saying no, which is correct. It is not possible. Okay, maybe it may be possible that out of 40 samples, we can satisfy 130 samples or 135 maybe 135 samples or 130 samples, and that's why we also calculate training accuracy. This is how the whole process takes place, and this is what is called supervised learning. This is what is done in supervised learning. So I think this is already discussed in the previous class, how different operations takes place. So we have two inputs, x1 and x2. We have two bias at both the places, b1 and b2. Okay. And weights w1, w2. These are the different weights. These are the different weights. So here the output y1 will be b1 plus x1 into w11. Y1 here will be, so I think it will be written maybe somewhere. Okay, not written. Y1 will be b1 into b1 plus x1 w11 plus x2 w12. Okay, similarly we'll calculate y2. Then we have another neuron, so we'll calculate y3, and this way the process goes on. Okay, these are called multi-layer. In normal neural networks, we will have one input layer and we'll have one output layer. But in multi-layer perceptrons, we'll have some middle layers also, and these layers are called hidden layers. I think it has been already discussed yesterday, so I'll not discuss about this here. Let us take one more example about how this numerical example about ANN, and then we'll go to another technique. So just see this problem. This problem is given to you. If possible, you can write it in your notebook. You can solve with me. That will give you better understanding. Okay. So we are given with a problem with two classes. Two classes are there. Okay. The two classes are 1 and 0. Sun and rose. Healthy, diseased. So like this, we can have two classes. Okay. And then we have two features also. We have two features also, and we have only three samples. To understand the concepts, I have taken only three samples. Okay, so what are the three samples? P1, first sample, P2, second sample, P3, third sample. So P1, P2, P3. P3. I have how many features? Two features. Let it be feature 1, feature 2. And then I have last column is always label or class. So P1 is the features values are 1, 2. You can see in this matrix 1, 2, and the class is 1. P2 is minus 1, 2. The two features are, the value of two features are minus 1, 2. The class is 0. P3 is 0, minus 1. The class is 0. Remember that when you apply this ANN and when you apply this machine learning, we need this type of table. We need features and the label. When you apply supervised learning, we need this type of table. Okay, so this problem is given to us, and we have to solve this problem. We have to develop a ANN model to solve this problem. We'll just see how this learning takes place. Okay, so the neural network architecture will be like this, correct? How many inputs we have? 2 only. How many features we have? Okay, so this is capital P. The notation that is written in the slide is this is capital P, and in the slide the features are represented by small p. This is small p1 and small p2. Okay, so this is small p1 and this is small p2. Two features, so their weights w11, w12. The summer and the output of summer is passed through a transfer function, activation function, and here we are getting the output. This is a simple neural network architecture which I am going to implement here. This type of transfer function is called hard limb transfer function. It is called hard limb transfer function. Hard limb is nothing but hard limb of any positive number, means number greater than equal to 0 is 0, and hard limb of negative number, sorry, this is 1 and this is 0. Hard limb of any number less than 0 is 0. Okay, this is the hard limb transfer function. I hope this is the complete question that is given to you. Also, we can plot this question like this. Just see, we can plot this question. There are two classes, 1 and zeros. We have two samples corresponding to 0 and we have one sample corresponding to 1. So I can plot this. The first sample is 1, 2. 1, 2. So this is x equal to 1, or rather I should say this is small p1 and this is small p2. Okay, so this is p1 is 1 and here it is 2, p1. P2 is minus 1, 2. P2 is minus 1, 2. So where will be the minus 1? Minus 1 will be here. Here we'll have p1 equal to minus 1 and then minus 1, p2, 2. So this point will be there. And similarly, third point is 0, minus 1. So 0 will be here, x-axis, and y-axis is minus 1. So I'll get here. The 0 class is shown by unfilled bubble, empty bubble, and 1 class is shown by filled bubble. Okay. So these are the two classes. These are the two classes. One class is this one green and the other is red. Other two are red. And I want to develop an artificial neural network model. How to do this? Now we'll solve it step by step. Start with selecting some initial weights. So we'll select some initial weight. Let it be 1 minus 0.8. Okay. We need this initial weights, right? These two weights, W1 and W2. So let W1 be 1 and W2 be 0.8. Okay. Then calculate N here. This is N. N will be what? N will be P1 into W1. P1 for the first sample. Take the first sample. This is for first sample, that is capital P1. This is for capital P1. For capital P1, what will be the value of model output N? Small p1 into W1 plus small p2 into W2. Small p1 is how much? For capital P1, small p1 is 1 into W1, which is 1, and p2 is 2 into W2. W2 here is what? Minus 0.8. This is the value of N. And the actual output A, model output A will be what? Hard limb of A. So if you solve this, this is equal to minus 0.6. So hard limit of n, and hard limit of minus 0.6 will be 0, because hard limit of negative is 0. So the model output given to you is 0, but the actual output is what? T1. Actual label was what? 1. It is 1. So it means that output is not matching. Output is not matching. The network has not returned the correct value. So the network output is 0, while the target response was 1. We wanted 1, but the network output is 0. So we'll update the weight or not? Can you tell me whether we will update the weight or not? Yes or no? Weight updation is required here? Yes, weight updation is required. How to update the weight? So I've just written one rule here to update the weight. Okay. In neural network theory, there are so many rules. Some rules you might have studied yesterday also. This is called unified learning rule. In unified learning rule, we first calculate the error. Error is t minus a. Okay, t minus a. And if error is 0, no change in weight. See the third equation. If equal to 0, new weight is equal to old weight. But if error is 1, new weight is old weight plus input. If error is minus 1, new weight is equal to old weight minus input. This is what is the learning rule. So same thing I am applying here. Because here when you calculate the error, error is what? T minus A. T minus A. And this will give me 0 plus 1. 1 minus 0. Because my target response was 1 and actual network output is how much? 0. So I'll get 1. If I'm getting 1, I'll use this equation. W new is equal to W old plus P. W new is equal to W old plus P. So W new, W old plus P. What was W old? W old means my initial weight. 1 minus 0.8. So see, 1 minus 0.8. So 1 minus 0.8 plus P. P is the input. What was the input in that case? My first input. मेरा first input क्या था? 1, 2. Correct? So I'll add 1, 2. I'll get 2, 1.2. This is my new weight. Why I have to find the new weight? Because previous weight was not working. Previous weight was not working. So I have to find the new weight. Now listen very, very carefully. This is a crucial step. You got new weight. You got new weight. With this new weight, that is 2 and 1.2, what you did initially, just a minute, let me rub this. So initially what I did, I gave P1 to the input, this first P1, right? 1 and 2. Now I will give the second input, P2, minus 1 and 2. With this new weight, 2 and 0.2. This new weight will be 2 and 0.2. Again, I will calculate N. And then A. This is what I'm doing here. And I'm getting 1. I'm getting output as 1. Whether this is what I required? No, I required 0. I required 0. Again, update the weight. In this case, E will be what? In this case, E will be what? T minus A. So T is the target output. My target was to get what? 0. But I got 1. Error is minus 1. Use second equation to update the weight. So again, W new equal to W old. W old was this, 2, 1.2 minus P, second input. Second input was what? Minus 1, 2. Again, perform subtraction. I'll get 2 minus minus 1, that is 3. And 1.2 minus 2 will be minus 0.8. I hope it is correct. Okay. This is my third weight. Now again apply this third weight here and take P3. And this process goes on. This process goes on until what? Until a point where I find for all three, P1, P2, and P3, I should get in their corresponding labels. I get their corresponding labels. You can try this problem at home. Maybe at 6th or 7th iteration, you will get such weight. You will get such weight. Whether everybody understood this learning, how this learning actually takes. This is what is learning. Learning means training of the model. And training means nothing. This happens when you train using A and N. This is what happens during the process of training. Did you all understood how this training, supervised training takes place? Okay. So this is so once this training is done, so this is a training process. Once this training is completed, we say that our model is developed now. Our model is built now. And since the model is built, it is ready for testing. It is ready for testing. Then you test the model and then you plot confusion matrix and you calculate accuracy, sensitivity, specificity, these things at the end. This is how the process continues. Now just imagine, see, for this is a very simple example, right? So we can do it manually also. We can find it manually. But just imagine in the real time scenario, we have 1,000 samples for training. Manually, it is not possible. Okay, and that's why we need this type of learning algorithms, and we need artificial neural network and other techniques. There are many other techniques also. Okay, coming to the next supervised learning techniques. Okay, so just a minute. Okay, let me talk first about unsupervised learning, and then if time permits, I'll take also one different, another second type of supervised learning, SVM, if time permits. Let's see, because we have, I think, less time. So this that what happened in supervised learning, in which label was available. Okay, in which the label was available. But in unsupervised learning technique, the label is not available with us. In unsupervised learning technique, the label is not available with us. In that case, we have to go for some other technique. Supervised learning cannot do the justice here. So because of the limited time, I will directly take the example. You will understand with this example. I assume that. I expect that. Sorry, I expect that. Okay. Anyway, if you have doubt, you can ask. So what in unsupervised learning, there are number of techniques. The two most popular are k-means, or the two most fundamental, I would say, k-means and fuzzy c-means. These are the two most popular techniques. Okay. So let us take the example and try to understand the concept of k-means clustering or k-means unsupervised learning. Okay. Consider the following 8 points, I would say 8 samples rather. Okay, 8 samples with 2 features, X and Y. So we have 8 samples, A1, A2, A3, A4, A5, A6, A7, A8. I have 8 samples. And these 8 samples are represented by 2 features. Say petal length, petal width, whatever you want to take. The values of those features are given in the brackets. So for first sample, it is 210. Second, it is 25. Third, it is 84, 58, 75, 64, 12. Okay. We have to divide this into 3 clusters using k-means clustering. We have to divide this into 3 clusters using k-means clustering. And for there is one, when we do k-means clustering, we need some distance calculation method or formula. So in the question, it is given that use Manhattan distance formula. Use Manhattan distance formula. I hope you understood the question. We have 8 points. 8 samples are given. In the previous neural network example, we had only 3 samples. Here we are given with 8 samples. And we have two features for each sample. We have to divide it into 3 clusters. So when I say K means, K is the number of cluster, and this means stand for mean actually. Mean calculation is involved in the process of K means clustering. Okay, so that's why it is called K means clustering. So how this K-means clustering is performed? Again, the process starts randomly. Here, label is not given to us. So the process again starts randomly because k equal to 3 given hai. K equal to 3 given hai. Let us divide the whole data set into 3 clusters first. पूरे data set को 3 clusters में divide करते हैं. But to divide them into clusters, we need cluster centers. We need cluster centers. Now, what are cluster centers? We need cluster representatives. So randomly, I chose A1 as a cluster center, A4 as a cluster center, A7 as a cluster center because K was equal to 3. So I chose 3 cluster centers, A1, which will be denoted by C1, A2, A4, which will be denoted by C2, and A7, which will be denoted by C3. Okay. Now what we will do, 3 cluster centers are there. Each point from A1 to A8 will now calculate the distance between cluster center and different points. Distance between cluster center and different points. And to calculate that distance, it was given that we have to use Manhattan distance. The formula is this. It is very simple. Mod of x2 minus y1, x2 minus x1 plus y2 minus y1. So how this is done? See here. We had 3 cluster centers. Cluster 1, the coordinate was 210. If you see the first cluster, the coordinate was 210. Okay. So first cluster coordinate 210, second cluster 58, third cluster 12. So 210, 58, 12, 3 clusters. These are the different points A1, A2, A3, A4, A5, A6, A7, A8. You have to now find distance between each point and each cluster. And for that, we will use this formula. We will use this formula. So for example, if I have to find distance between A1 is the cluster center 1 and A3. तो A1 का coordinate हो गया कितना? 210. A3 का coordinate, it is given how much? 84. So if I apply this distance formula, how the distance will be calculated? The distance will be calculated as this. The formula is simply x2 minus x1. x2 minus x1 plus y2 minus y1. So assuming that this is x1 y1 and this is x2 y2. So 8 minus 2 plus 4 minus 10. I'll get 6 plus, this is how much? Minus 6, which is again 6. So I'll get 12. So the first cluster distance between third point and first cluster center will be 12. Similarly, you have to find all the distances. Like for example, if I want to find distance between A5, that is 7, 5. The coordinate value is 7, 5 and with third cluster 1, 2. So 7, 5 with 1, 2. So the answer will be very simple. Mod of 7 minus 1 plus 5 minus 2. So it will be mod of 6 plus mod of 3, which is how much? 9. So I will get what? 9. Okay. If I want to find the distance between 1, 2, that is the 7th point, and cluster center 5, 8, second cluster. So 1, 2 and 5, 8. It is very simple. Mod of 5 minus 1 will be 4, 8 minus 2 will be 6, 4 plus 6 will be 10. In this way, you have to find the distance between all the cluster centers and all the points. And then you have to see which one is the smallest distance. Which one is the smallest distance? A1, the distance of A1 from first cluster is 0. Obviously, with first cluster, it will be 0. Why? Because A1 itself was chosen as cluster center. A1, this is nothing but A1 only. A1 was chosen as cluster center. A4 was chosen as cluster center. And A7 was chosen as cluster center. तो A1 का distance 0 होगा, A4 का 0 होगा, और A7 का भी 0 होगा. Distance between A1 and A4 is 5. A1 and A7 is 9. So it means that the point 1 lies in cluster C1. Now the last column is important, okay? The point A1 lies in C1. A2 lies in C3. See, A2's distance first के साथ 5 है, दूसरे के साथ 6 है, third के साथ 4 है. So A2 lies in C3. A3 lies in second cluster. A4 lies in second cluster. A5 lies in second cluster. Second wala small hai. A6 again lies in second cluster. A7 lies in third cluster. A8 lies in second cluster. So in first cluster, you got only 1 point. In second cluster, you got so many points. In third cluster, you got 2 points. After this step, now you find new cluster center. Initially, we took randomly that let A1, A4, A7 be the cluster center. But now we'll find new cluster centers. So what will be the cluster center for the first? It will remain A1. Why? Because we have only 1 point in this. We have only 1 point in this. So it will not change. But for the second cluster, the cluster center will change. You'll have to calculate the mean of all the values. 8 plus 5 plus 7 plus 6 plus 4 plus 4 divided by 5. And similarly, 4 plus 8 plus 5 plus 4 plus 9 divided by 5. You have to calculate the average of both the points, x coordinate and y coordinate. Okay. And for cluster 3, we have only 2 points, A2 and A7. So I'll calculate their mean. So I got uh, new clusters. The first new cluster is what? The A1 itself. Second one is what? 6, 6. Third one is what? 1.5, 3.5. Again, I will repeat the whole process. I have 3 cluster centers, C1, C2, and C3. I will find the distance of each point. I will find the distance of each point from C1, C2, and C3. Again, I'll find new cluster centers. The process will continue till the time the cluster centers stop changing. The old cluster center and new cluster center are almost same. Till this thing happen, the process will continue. Is it clear to everyone? I'm waiting for your answer. Is it clear to everyone? This is how unsupervised learning takes place. Okay. So, So center of the newly formed clusters do not change. Repeat the previous steps until the center of the newly formed clusters do not change. The data points remain present in the same cluster. Okay, this is also the criteria that though the cluster center is changing, but the data points in a particular cluster are not changing. Sometimes one more criteria is there, the maximum iterations are reached. That suppose the algorithm runs 100 times. We have in our algorithm, we have made that setting that the maximum number of rounds is 100. Then also the algorithm will stop. Okay, this is how unsupervised learning takes place. So this is, I hope you got the understanding of what is supervised and what is unsupervised learning. I'm just checking one paper. I think I'll not discuss SVM. I'll just discuss one of my old paper that is in 2016. We used one we used this supervised and unsupervised learning in one of our papers. So I'll discuss it and then I'll end it. Just a minute. Okay. Can you all see this? Is this visible to all? Okay. So this was the topic, that is fuzzy cluster based neural network classifier for classifying breast tumors in ultrasound images. Okay. So we have a database, and that database consists of ultrasound images which belongs to two different categories. One is malignant and other is benign. So cancer and non-cancer. Okay, this is also a kind of some suspicious area. Benign is also a type of, you can say, some fat deposition, but it is not cancer. And malignant means cancer. So we had data of these two categories. Okay. So we did the similar like approach, neural network, support vector. I think this we used fuzzy C-means and neural network. We combined supervised learning and unsupervised learning for classification of breast cancer. Okay, so we had total number of images 178, benign images 88, malignant images 90. Okay, I'll not explain all the steps. Like initially we did some pre-processing. Pre-processing means simply removing the noise from the images, because ultrasound images are highly corrupted by noise. For example, there is a noise called speckle noise, which is inherently present in the ultrasound images. Okay, so the first step is to remove that noise, and we use some techniques to remove that noise. Okay, after that, after noise removal, we did feature extraction. So we extracted approximately 457 features from these images. Okay, 457 features, like 447 texture and 10 shape. 10 were related to shape features, because tumor, yeah, shape in tumor is also very important. What is the area of the tumor? What is the perimeter? What is the height by width ratio? These things play important role in classification of tumor. Okay, and then texture is also important in tumor. Whether the texture is homogeneous, heterogeneous. If it is heterogeneous, it is more towards cancer. If it is homogeneous, it is more towards normal. Okay, so these criterias are there. So we extracted 457 texture and shape features, and then we did some feature selection also. 457 features were reduced to, I think, I don't exactly remember, 19 features. The 457 features were reduced to 19 best features using feature selection. Okay, that is a pipeline of machine learning. And then for classification, yeah, for classification, two techniques were used: BPANN and SVM. So this is fuzzy paper, right? Yeah. So BPANN and SVM. BPANN stands for back propagation artificial neural network, and support vector machine stands for SVM stands for support vector machine. Okay. See, these are the features which we extracted. First order statistics, so many features were there. So, and then the procedure of combining supervised and unsupervised learning was like this. See here, we had an image database We did pre-processing to remove the noise. We did feature extraction, then feature selection. After feature selection, the data was divided into two parts, training and testing. You might have already, you are studying from last 2 days, what is training, what is testing. Okay, so training and testing. The training data was first given to fuzzy C-means clustering. Okay, and then what was happening? We number of clusters were selected to equal to 2. C is equal to 2. So 2 clusters we got. We don't know whether it is benign or malignant. Initially, we just got 2 clusters. Okay, because we are applying FCM. In FCM, label is not required. We didn't give the label in FCM. Okay, so we give all the samples. We gave all the samples, and that samples were grouped into 2 categories by FCM. That is cluster 1 and cluster 0. Cluster 0 and cluster 1. Later on, what we did, we analyzed that which samples are there in cluster 0 and which samples are there in cluster 1. Okay, so for example, see this one, see this table. These are 8 samples just for illustration. Okay, these are not actual image values. 8 samples, 3 features. We had 19 features finally, so this is just an illustration. These are simply features, and this is my label. 0 is benign, 1 is malignant. Okay, when this was given to FCM, we got 2 clusters. In first cluster, 1, 3, 4, 6 were there. Sample number 1, 3, 4, 6. And in the second cluster, others were there. When we analyzed it, so analyzing means what we did is we re we retract we tracked the label actually. We didn't give the label here. Label was not given here, but what we did, we analyzed that the sample which is in one cluster, what were their labels. Actually, labels were available to us, but we didn't give it in FCM. So we gave 0. When we analyzed, we found that the first sample corresponds to 0. The third sample also corresponds to 0. The fourth sample also corresponds to 0. But sixth sample corresponds to 1. Similarly, we did for this one. 2, 5, 7, 8. These 4 samples were in the second cluster. So we analyzed what were their actual ground truths. So it was 1, 1, 0. So like that, we tracked 1, 0, 1, 1. When we analyzed, we found that the most of the samples in this group are belong to 0 class, and most of the samples in this group belong to 1 class. So we call this as benign cluster and this as malignant cluster. And after that, the sample which was different in the cluster, like here 6 sample belongs to 1, but it is now in the benign cluster, and the 5th sample is in the malignant cluster, but it is actually benign. So we consider these as doubtful samples. It from the training data. We eliminated into the it from the training data. So my new training samples were 1, 2, 3, 4, 7, 8. We eliminated what? We eliminated 5 and 6. We eliminated 5 and 6. Are you getting my point? So what we did here is that by using fuzzy C-means clustering, we cleaned our training data. We eliminated the faulty training samples. And once the faulty training samples were eliminated, the cleaned good training samples were given to the model, were given to the neural network model for training and testing. Okay, so that was simply classification. For neural network we used for what? Classification. Okay, so there is no more block diagram. I think there was one block diagram here. Just a minute. Yeah, this way. See, so we eliminated the doubtful samples, or we can say the mismatch cases. Combine the refined training data. Okay, just a minute. So After getting this refined data, we trained our backpropagation artificial neural network model. Okay, and that trained model was then used for classification of benign and malignant on the new data, that is the test data. This is what we did in this paper. In this paper, we combined supervised and unsupervised learning for classification of cancer, that is benign and malignant. Okay, so I think with this, I will stop here. Uh, if you have any questions, you can ask. Otherwise, I'm open to questions now. I think time is over, almost over, I think. So we can now keep maybe 5 or 10 minutes are remaining, so we can keep it for question answers. Okay.
Yeah, thank you, sir. Now I request the participants, if they are having any question, they can raise their hand. I will unmute them so they can ask a question directly to the sir.
Or you can write in your chat box,
Yeah.
so I can see the questions. I will answer. Any question from the participants? If there are no questions, at least you can write that there are no questions.
Participant can ask a question. Yeah, someone has written that session
No
was
question
nice,
is
sir.
not there. Yes. Thank you.
Okay,
No
thank you.
question.
Thank you, Professor Dr. Bikesh Singh, sir, for speaking at 1 week TEL FDP organized by Rumta College of Engineering and Technology, Bhilai. Your presentation on neural network and its application was very knowledgeable and was very well received by our participants. Thank you, sir. Thank you for taking the time.
Thank you, Pradeep, and thank you for hearing this long session. To the participants also, thank you, Pankaj Mishra sir. Thank you very much for inviting me in this workshop. Thank you very much.
Thank you, sir.
So
Once
can
again,
I
I thank.
leave?
Yes, sir.
Okay.
Yes, sir. Once again, I thank you, sir, for enriching
Okay.
our event with your presence.
Okay.
Thank you, sir.
Okay. Thank you.
Now I request our participant that we will be having our session at 2:30. Sir will be joining soon. He has not joined. We are having the speaker, Dr. Subhajit Ghosh from NIT Raipur. He is from electrical department. And the topic on which he will be delivering his session will be on how learning differs from pure optimization. So we will wait for the sir to join, and we will hope so. We will be having our session starting from the 2:30 p.m. We are taking a 5-minute break. Thank you.